You are tuned to Iri-e-learning and I am your host, Teacher. In this structure bonding lesson, we will examine part 2 of writing chemical formulae. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to deduce the stability numbers for atoms and radicals. Write chemical formulae for simple ionic and covalent compounds containing radicals and transition metals. We will begin with a quick recap or review of the stability number. Recall that the stability number is the number of electrons an atom will lose, gain, or share to achieve a stable electron configuration, as well as we can use the periodic table to determine the stability number of an atom. And first, we need to identify the group number because the group number will tell us how many electrons are on the last shell. Once we know the number of electrons on the last shell, we can use that to determine whether the atom will gain, lose, or share electrons. Just remember that atoms in groups 1, 2, and 3 will contain 1, 2, and 3 electrons respectively. And when they have less than 4 electrons on their last shell, they will lose all their valence electrons to become stable. On the other hand, atoms with 4 or more electrons, between 4, 5, 6, and 7 electrons, they will either gain or share electrons to fill their last shell to the maximum of 8 electrons to become stable. We will now focus on writing chemical formulae that contain radicals. You might be wondering what a radical is. Well, radicals are a group of atoms that are covalently bonded together to form stable polyatomic ions. Poly meaning many, so polyatomic would be many atoms in the ions. And these polyatomic ions can either have positive or negative charges. In most cases, we can easily identify radicals because their names often end with ate, ate, or ite, ite. There are a few exceptions. We will identify those when we look at the examples of radicals. A few examples of radicals include hydroxide. Hydroxide is one of those exceptions. Chemical formula OH, it contains oxygen and hydrogen, and the overall charge is -1. Seeing that there's only one negative charge, the stability number is 1. There is nitrate, NO3, negative, and nitrate consists of 1 nitrogen and 3 oxygen atoms bonding together to form a stable ion which has a charge of -1. As a result, the stability number is 1. Ammonium is one of the radicals in which the name does not end with ite or ate. Ammonium is a polyatomic atom that consists of 1 nitrogen atom bonding with 4 hydrogen atoms and forming a stable ion that has a charge of +1. As a result, the stability number of ammonium is 1. There is bicarbonate, also known as hydrogen carbonate, HCO3. In this polyatomic ion, there is 1 hydrogen, 1 carbon, and 3 oxygen atoms bonding together to form a stable ion having a charge of 1 negative. As a result, the stability number is 1. There is carbonate, CO3 2-. This radical consists of 1 carbon bonding with 3 oxygen atoms, forming a stable polyatomic ion with a charge of 2 negative. And seeing that there are 2 negative charges, the stability number is 2. Sulfate is also a radical. It consists of 1 sulfur bonding with 4 oxygen atoms and having a charge of 2-. As a result, the stability number is 2. For this course, we will only look at 7 radicals. So the final one is phosphate, PO4 3-, 1 phosphate atom bonding with 4 oxygen atoms and having a charge of 3 negative. As a result, the stability number is 3. So if you notice, for the radicals, the stability number is just the quantity of charges, whether positive or negative. So if it has 1 negative charge, then the stability number is 1. If there is 1 positive charge, the stability number is still 1. The first example, including a radical, is sodium hydroxide. Sodium is an element from our periodic table, and hydroxide, as we just learned, is a radical OH-. Stability number 1. So let's take a quick look at the periodic table to get the symbol and stability number for sodium. Sodium symbol Na is located in group 1. Therefore, sodium has 1 electron on the last shell, which it loses to become stable. Consequently, the stability number of sodium is 1. We will follow the steps for writing chemical formulae. Step 1, write the formula of any element or radical in the compound. Na for sodium, and OH for the radical hydroxide. Note that the formula of the radical is placed in brackets or parentheses. Step 2, write the stability numbers to the top right of the symbols. Both sodium and hydroxide have a stability number of 1. When recording the stability number of the radical, make sure to write the number outside the bracket at the top right. Step 3, cross over the stability numbers to the base of the adjacent element or radical. So 1 goes to the base of hydroxide and 1 to the base of sodium. Make sure to write the base number for the radical outside the bracket at the bottom right. If the base number is 1, it is erased and not written in the chemical formula. Also, if the base number for the radical, as in this case, is 1, we remove the brackets from around the formula of the radical. Therefore, the chemical formula for sodium hydroxide is NaOH. The second example is ammonium sulfide, where ammonium is the radical and sulfide, remember when it ends with "ide," we know that's coming from the atom. So sulfide comes from sulfur. Also note that there's an alternate spelling for sulfide instead of the PH giving the F sound. Many science books are using F instead of PH, and it's still pronounced sulfide. So let's take a quick look at the periodic table to obtain the information, that is the symbol and stability number for sulfur. Sulfur, symbol S, is located in group 6, so sulfur has 6 electrons on the last shell. When subtracted from the maximum capacity of 8 electrons on that last or third shell, the result is 2. Hence, sulfur needs 2 electrons to become stable. As a result, the stability number for sulfur is 2. Step 1, write the formula of any element or radical in the compound. NH4 for the ammonium radical and S for sulfur. Note that the formula of the radical is placed in brackets or parentheses. Step 2, write the stability numbers to the top right of the symbol. The stability number of the ammonium radical is 1 and that of sulfur atom is 2. When recording the stability number of the radical, make sure to write the number outside the bracket at the top right. Step 3, cross over the stability numbers to the base of the adjacent element or radical. So 1 goes to the base of sulfur and 2 to the base of ammonium. Make sure to write the base number for the radical outside the bracket at the bottom right. If the base number is 1, it is erased and not written in the chemical formula. When the base number of the radical is greater than 1, as in this case it is 2, the brackets are kept around the formula of the radical. Therefore, the chemical formula for ammonium sulfide is open brackets NH4 close brackets 2S. The third example is calcium carbonate, which comprises the element calcium and the radical carbonate. We looked at calcium in a previous example, so we know that the formula is Ca and the stability number is 2. The radical carbonate has the formula CO3 and a charge of 2-, therefore the stability is 2. So we can go right into the steps for writing the chemical formulae. Step 1, write the formula for any element or radical in the compound. Ca for calcium and CO3 for carbonate. Note that the formula of the radical is placed in brackets or parentheses. Step 2, write the stability numbers to the top right of the symbol. The stability number for calcium is 2 and that of carbonate is 2. Make sure to write the stability number for the radical outside the bracket at the top right. Also note that there's a common factor between the two stability numbers. Step 3, divide each stability number by the highest common factor, which is 2 in this example. Both stability numbers are divided by the highest common factor of 2, which brings it to the lowest possible ratio between the calcium and the carbonate. Step 4, cross over the stability numbers to the base of the adjacent element or radical. So 1 goes to the base of carbonate and 1 to the base of calcium. Make sure to write the base number for the radical outside the bracket at the bottom right. When the base number is 1, it is erased and not written in the chemical formula. Also, when the base number of the radical is 1, the brackets are removed. Therefore, the chemical formula for calcium carbonate is CaCO3. The final example for this section is ammonium sulfate. Here we have two radicals involved in the chemical formula. Also note the alternate spelling for sulfate. That is, it uses an F instead of PH. However, it does not change the pronunciation. Step 1, write the formula of the radicals in the compound NH4 for ammonium radical and SO4 for sulfate radical. Note that the formulae of the radicals are placed in brackets or parentheses. Step 2, write the stability numbers to the top right of the symbols. The stability number of the ammonium radical is 1 and that of the sulfate is 2. When recording the stability number of the radicals, make sure they are written outside the bracket at the top right. There is no common factor greater than 1, so we can move to step 3 where we cross over the stability numbers to the base of the adjacent radicals. So 1 goes to the base of sulfate and 2 to the base of ammonium. Make sure to write the base number of the radical outside the bracket at the bottom right. When the base number is 1, it is erased and not written in the chemical formula. Remember, the numeral 1 is never written in a chemical formula. Also, since the base number of the ammonium radical is greater than 1, the brackets are kept around its formula. Therefore, the chemical formula for ammonium sulfate is open brackets NH4 close brackets 2 SO4. Now we're on to the final section of writing chemical formulae, where we're going to introduce transition metals as well as post-transition metals. Examples of common transition metals we need to know at this level include iron. When iron bonds, it loses 2 electrons to form a stable metal ion called iron 2, symbol Fe2+. Therefore, the stability number is 2. Iron is also unique in that it can also bond to become stable by losing 3 electrons, forming the metal ion called iron 3, symbol Fe3+. Therefore, the stability number is 3. When copper bonds, it loses 2 electrons to form the stable metal ion called copper 2, Cu2+. The resulting stability number is 2. Zinc loses 2 electrons to form the stable metal ion Zn2+, hence the stability number is 2. Silver loses 1 electron when it bonds to form the stable metal ion Ag+, hence the stability number is 1. Lead, a post-transition metal, loses 2 electrons when it bonds to form the stable metal ion Pb2+. Thus, the stability number is 2. The first example for this section is silver nitrate. Silver is a transition metal and nitrate is a radical. Step 1, write the formula of the elements or the radicals in the compound, and of course we have silver, which is Ag, and nitrate, which is NO3. And because nitrate is a radical, we have placed the formula in brackets. Step 2, write the stability numbers to the top right of the symbols. So the stability number for silver is 1 and the stability number for nitrate is 1. So that takes us to step 3, where we'll cross over the stability numbers to the base of the adjacent element and radical. Keep in mind that when the base number is 1, we do not write it in the formula. And when the base number to the radical is 1, we also delete or erase the brackets from around the radical. So the chemical formula for silver nitrate is AgNO3. The second example for this section is iron 2 chloride. Remember, iron is a transition metal and the 2 indicates the stability number or the charge on iron. Chloride ending in "ide" tells us that it's coming from the atom, so we're talking about chlorine. And we looked at chlorine in an earlier example. We know that the symbol is Cl and its stability number is 1. So we can get straight into our steps. Step 1, where we're going to write the symbols of the elements in the compound. Step 2, we're going to write the stability numbers to the top right of the symbols. And step 3, we're going to cross over the stability numbers to the base of the adjacent elements. So 2 goes to chlorine and 1 goes to iron. Of course, when the base number is 1, we do not write it in the formula. So the formula for iron 2 chloride is FeCl2. The final example for this section is lead sulfate. Of course, lead is a post-transition metal and sulfate is a radical. Step 1, we're going to write the symbols of the elements and the formula of the radical inside this compound. So lead is Pb and sulfate is SO4, and because sulfate is a radical, we put the formula in brackets. Step 2, we're going to write the stability numbers to the top right of the symbol. Note that both lead and sulfate have a stability number of 2, and of course you may have already recognized that there is a common factor greater than 1, so we move to the next step where we're going to divide through by the highest common factor, and that factor of course is 2. So we divide each stability number by 2, and then that brings us to the final stage where we cross over the stability numbers to the base of the adjacent element or radical. And just remember, if the base number is 1, we do not write it in the formula. And also if the base number of the radical is 1, we erase or remove the brackets surrounding the radical. So the formula for lead sulfate becomes PbSO4. It's time for a quick lesson summary. Atoms bond or react to obtain a stable electron configuration. The stability number of an atom is the number of electrons it will gain, lose, or share. Atoms in groups 1, 2, and 3 become stable when they lose all their valence electrons. Atoms in groups 4 to 7 will gain or share the number of electrons needed to complete the octet, that is, to gain 8 electrons on their last shell. The steps for writing formulae: record the symbols with the stability numbers written at the top right. Bring the stability numbers to the lowest ratio. That involves dividing the stability numbers by their common factor greater than 1. Then finally cross over the stability numbers to the base of the adjacent symbols. Never write the numeral 1 in a chemical formula. Remove brackets from around the formula of a radical if the base number is 1. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. Magnesium is in group 2 and fluorine is in group 7. What is a chemical formula for magnesium fluoride? A. Mg2F7, B. Mg2F, C. Mg7F2, D. MgCl2. The answer is D. MgCl2. Question 2. What is the name of the compound that has the chemical formula Fe2O3? A. Iron 2 oxide, B. Iron 3 oxide, C. Lead oxide, D. Iron 2 trioxide. The answer is B, iron 3 oxide. Recall that the stability numbers are crossed over to the base of the symbol of the adjacent element. Therefore, the 3 at the base of oxygen is the stability number of iron, making it iron 3. Question 3. Aluminium, Al, is in group 3. It forms a compound with the nitrate radical NO3-. What is the chemical formula of the compound? A. Al, open brackets, NO3, close brackets, 3. B. Al3NO3. C. Al3, open brackets, NO3, close brackets, 3. D. AlNO3. The answer is A. Al, open brackets, NO3, close brackets, 3. Look to the right of the screen and you'll see how we arrived at our answer. Question 4. Boron B is in group 3 and combines with the phosphate radical PO4 3- to form a compound. What is the formula of the compound formed? A. B3PO4, B. B, open brackets, PO4, close brackets, 3, C. BPO4, D. B, open brackets, PO3, close brackets, 4. The answer is C. BPO4. Take a look to the right of the screen and you'll see how we arrived at our answer. Question 5. Lead ions Pb2+ reacts with nitrate ions NO3- to form lead nitrate. Identify the formula of lead nitrate. A. Pb2NO3. B. Pb brackets NO3 close brackets 2. C. Pb open brackets NO2 close brackets 3. D. Pb open brackets NO close brackets 3. The answer is B. Pb, open brackets, NO3, close brackets, 2. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.